So I think
You're ready to roll?
they're not second.
Okay, let's begin. Let me have your attention. Let's begin. It's my privilege to welcome you to the University of Tennessee Nuclear Engineering Department seminar. Before I introduce today's speaker, there are some students I'd like to recognize. In particular, we had about 20 students, along with Dr. Hines, attend the recent A&S Student Conference at Penn State, and 3 of our students walked away with awards, and I think 2 of them are here. I want to ask them to stand up, and let's give them a round of applause. First of all, there's Aaron Sawyer. Aaron, stand up. And Shaydong Wong, please stand. And Ibrahim's not here yet, but let's give these students. Okay, this is our last scheduled seminar for the semester and for the year, and we may have saved the best for last. So, time will tell. Today's speaker is a new division director at the Oak Ridge National Laboratory. It's Mr. Joe Herndon, and he's one of our own graduates, that is, in mechanical engineering. He received a BS and an MS in mechanical engineering. He's been a division director in the robotics division at ORNL. He was an R&D 100 award winner. He has over 8 years experience as a division director at ORNL, and he's currently the new interim division director for the Nuclear Science and Technology Division, a new division at the Oak Ridge National Laboratory. And the title of his presentation today is an overview of the R&D activities of this new division. Joe, welcome.
Thanks, Lee. Lee and I talked a little bit, at least by email, about what I was going to talk about today, and my background, Tom Shannon knows it very well, we work together a lot, is in the nuclear fuel cycle, particularly in more recent years in nuclear remote handling and robotics, where I spent most of my time, particularly in the last 15 years. So I thought about doing a technical presentation today on nuclear remote handling, which is probably not a field you hear a lot about over here, but yet it's a very important field to the endeavor of nuclear energy. Brad Nunn certainly remembers some of the work we did in the early years in remote handling at Oak Ridge. But it was overwhelmed by my desire to begin a dialogue between this department, well, not to begin it, but to maybe enhance the present dialogue and grow it in with this new division at Oak Ridge. We have a new division with, I think, a very important mission to Oak Ridge National Laboratory, and very obvious desire on my part and the staff there to have a good, positive, and growing relationship with this department. So I decided that today would be the time that maybe we could talk to each other about what we're doing out at the lab and how we relate to each other. So that's what I'm going to do. So what I'll do is give you a little bit of overview of the division itself, where it came from. A lot of you in the audience have a background in relating to Oak Ridge. Some of the things we're doing, the research areas, who the key people are, which is probably the most important thing you might want to know. Who's leading what parts of the research out at Oak Ridge these days, and then I'll make some concluding remarks from that. Good. Okay. By way of background, the Nuclear Science and Technology Division is new. It was established by ORNL in October of this past year. And the idea is to provide a new focus on the nuclear and complementary research and development staff, the facilities, and the programs at ORNL. Well, why did we do that? We did that because we wanted to demonstrate a renewed commitment to the nuclear enterprise as part of the portfolio at ORNL, which I think you all will recognize is a is important. Also, we wanted to position ourselves to respond to renewed interest in nuclear research because we think there's really a lot of support happening right now for the nuclear enterprise across the United States with the nuclear energy strategy that are embedded in the national energy strategy and all the things that we think in the near future are going to lead to more research in this area and to we hope, renewed deployment of nuclear plants in the United States. For those of you that are familiar with ORNL, we are a new division, the division I head is formed from pieces of 6 historical divisions that many of you will recognize: computational physics and engineering, chem tech, which was around from day one in ORNL, engineering technology, instrumentation and controls, life sciences, and my old division, robotics and process systems. And we're in the energy and engineering sciences directorate. And then very recently, on January 1, additionally, a portion of the nonproliferation and national security groups, which have historically been at the Oak Ridge Y-12 plant, recently joined with us too, which really completed the portfolio of capabilities that we feel like we need for the future. You know, if you put the cursor on the back button, that's what you get, right?
Yeah, right.
So we'll see what I'll do. I'll be qualified by the end of this talk. Okay, NSTD is now the largest R&D division at Oak Ridge National Laboratory. There's 380 staff and 104 guests in this division. We have over $140 million in funding this year, and that's still growing. We haven't got it all, but that's where we're at right now. We do have the majority of all of ORNL's nuclear research staff, the nuclear facilities, and the infrastructure related to nuclear R&D. So this really is a major recommitment by the lab to break down a lot of the old stovepipes and invest in making nuclear important for the lab. We also have a lot of unique research and development facilities. This includes all of the hot cells for heavy actinide production at the lab. That's the Building 7920 in the Radiochemical Engineering Design Center. Also the hot cells for Californium-252 production at 7930. We have 2 major facilities devoted to the production and storage of medical industrial isotopes. And along with that, we are now the DOE's National Center and Business Office for the production and distribution of all radioisotopes by DOE. We have some hot cells related to radiochemical separations and conversion in our old Building 4501, and we also have a special nuclear materials vault. You should never put up org charts in a seminar, but just quickly, I wanted to let you know where we fit. A number of you, let's see here now, can I get it right? Here we go, right switch. Many of you know Gil Gilliland, who's the Associate Laboratory Director in Energy and Engineering Sciences, and you can see this division reports to Gil. In my division, we sure won't look at this one in detail, but there are 22 groups in this division representing the 380 staff and over 100 guests where we accomplish our work. Okay, well, let's get down to what we do. I tried to organize these 22 groups into something that will make a little bit of sense to you logically in groupings. And these are the major areas that we do R&D today at Oak Ridge. We do work in nuclear power systems, nuclear computational analysis, and I suspect you probably have more ongoing relationships with groups in these 2 areas than any others right now, particularly with the computational people, I think, that are in this grouping. We have the chemical processing system design groups where we do our radiochemical processing and isotope production work. We operate a number of nuclear facilities, and we create and distribute stable and radioactive isotopes for use for medical and industrial uses all over the world. We have new capabilities in nonproliferation and national security areas. You've had a speaker from our Transportation Technologies group about 2 or 3 weeks ago, so you probably know most of what we do there. And we also have a couple of groups who specifically deal with designing nuclear and radiochemical processes and implementing remote handling systems in all of these facilities to allow you to operate them remotely. Let's talk a minute about the nuclear power systems. And I want to call your attention to, if you have questions and you'd like to start a dialogue, I intentionally, in every, I'll get the right switch right. I've intentionally, in each one of these slides, which you can of course pull up from the archive, I've listed who the group leader is and their email address. I encourage you because we're very interested in building relationships in all these areas. I've made sure you know who the contact is, and I encourage you to get a hold of that person. Many of them you'll probably already know from past workings. So please, I encourage you to contact our group leaders who are now in this organizational construct we have at the lab, are the key people and the technical leaders who manage their areas. Our first nuclear power group is the Advanced Reactors and Fuels group. Many of you know Gary Mays, who leads that group. The focus on that group is advanced reactor development and applications. We do fuels development, qualification, and we do a lot of fuel cycle analysis. They focus a large percentage of their work these days on the fissile material distribution program, looking at the U.S. and Russian surplus plutonium and the projects related to dispose of that plutonium. They also have a major new effort, and we think this is a significant growth area for the future, renewed interest by NASA in particular in fission nuclear power technologies for space applications, both for propulsion and for power production. We think this is going to be a significant new area, and there's going to be significant growth in research in that area. We have some NERI work in advanced reactor and Gen 4 roadmap work in this area, and we also support the State Department in international fuel cycle work. Advanced Nuclear Measurements and Controls. Y'all may recognize this as the group that's been classically led by Jim White. I don't see Bob Urey. He must be out of town today. Bob has worked, I know, many years with this group, and Bob is also a member of the staff in my division as well as faculty here. Jim's group does primarily reactor control, reactor modeling, safety analysis, and supports all aspects of the reactor development groups at the lab. They also do a lot of work, and some of you are familiar with the work that they do, fissile material detection and characterization in various locations, including internationally in Russia and other places. Grady Yoder heads a group in the division that deals with thermal hydraulics and radiation engineering. Many of you know Ken Toms and his work in irradiation studies, capsule development. He does irradiations at the HIFA reactor at Oak Ridge, at ATR reactor at Idaho, and the Ford reactor for all kinds of applications, material studies, and the like. This is the group where we do our thermal hydraulics work with a lot of the focus. Difficult to see in this view graph, but a lot of the thermal hydraulics work for the spallation neutron source target is done in this group, as well as all of the full-scale testing in the division. And then our third group in the reactor area is the Nuclear Safety and Operations Group. This group is headed by Don Williams. This is a group that centers in the areas of the safety analysis, support, risk assessments, and economic kinds of analyses that we do for both DOE and the Nuclear Regulatory Commission. Risk modeling, licensing activities, and support to safety analysis, and all of these cross-cutting kind of things. In the nuclear computational analysis area of the division, and again, there's probably more direct relationship here in this area, I think, Lee, than probably any other part of the division at this time. First group is Dan Ingersoll's group, who I know you have a very direct relationship and are working together on LDRD projects and cooperating on potential NERI projects. Dan's group does the large-scale modeling and simulation of nuclear systems and environments, reactors, accelerators, and you can see some of the modeling work for the spallation neutron source. They've done a lot of the transport modeling work related to the spallation neutron source. And they do modeling of all kinds of reactor types. Cecil Parks' group, Nuclear Analysis Methods and Application, really is our nuclear criticality safety group at Oak Ridge. Fred, I'm sure you're familiar with this group from years back. They have the production software and the key policy staff related to criticality safety analysis and applications. They travel the world over and train people on nuclear criticality safety, as well as doing a lot of work in the area of nuclear fuel cycles, fuel type analyses also. And then the third nuclear computation group is a group headed by Bernadette Kirk, and I'm sure most of the people in the room at least have heard of RSIC, which is the software repository for and an international resource to preserve all of the nuclear science software, data, and related information, and serves customers all over the world, and they have over 1,500 software packages that are available for use. And the other part of that group's mission is to work in the ORNL facility in Oak Ridge and develop nuclear data, which will back up our modeling codes. Moving from the reactor and reactor modeling and fuel cycle modeling work into the chemical processing systems capabilities of the division, this is a classic and historical capability of Oak Ridge National Lab. If you remember back from your history books, not from being there, that Oak Ridge primarily was founded in the 40s to demonstrate the ability to operate a reactor and to generate very small quantities of fissile material, and that was the genesis of the chemical processing capabilities at Oak Ridge, which are there from day one to separate plutonium from graphite reactor fuel. Working in the 3019 facility at Oak Ridge. Today we have an extremely diverse set of research programs in chemical processing, and they range from very fundamental work all the way through to deploying chemical processes for actual applications on site in Oak Ridge. Starting with the fundamental research group in the division, this group is led by David DePauli. The separations and materials research group conducts basic and applied research through all kinds of aspects of not just nuclear, but all the complementary energy areas, carbon management, and even waste treatment. This is our fundamental work. We do, every once in a while I hit the wrong switch, but I'm getting to where I can recover from it. We have operate chemical physical properties research facility. We do cluster computing for chemical modeling. We do some of the more cutting-edge chemical processing modeling work that's going on. They work in the fossil area, the carbon sequestration area. All of this, though, of course, is founded on the capabilities to do separations kinds of work in the nuclear area. We have a process chemistry group, which kind of serves as the bridge between the fundamental chemistry group and the chemical process applications group. This group was led, for those of you that know him, by Leon Klatt up until a couple of months ago when Leon finally decided to retire from the lab. And we're in the process of selecting a new group leader for this group. These guys, as I indicated, really are the bridge, the chemical engineering bridge between the fundamental research and the applications. Their primary area of work includes U-233 recovery, and this is the group where we're doing right now our early work in restoring our capability in particle fuels fabrication at Oak Ridge, which is a major new initiative that I'll talk about a little bit later. They do thermodynamics and process modeling and membrane separation. Then in the third area, Process Engineering Research Group, this is the more full-scale chemical process applications group at the lab. They operate the chem processes in laboratory and hot cell facilities and develop hot cell-oriented and size-scaled chem separations equipment for various isotope production, waste processing, fuel processing. These are the people who maintain the capability for full-scale nuclear fuel cycle work. If the National Energy Strategy leads us back into the full-scale work in nuclear fuel cycle, which we hope someday it will, then the large-scale plant work will be done here. Finally, we have a major project going on today to take the UF6 that was, for those of you that know about the molten salt reactor experiment, we removed a lot of U-233 from that reactor in the form of UF6, trapped that on NAF traps and have that fuel material, I guess, fissile material in storage today at Oak Ridge. We're in the process of implementing a process to capture that U-233 and return it for long-term storage in a stable form. That's one of our largest projects right now, and as you know, since U-233 tends to come with significant quantities of U-232 in it, this is probably as highly radioactive a process as we do in Oak Ridge. So, significant challenge for us. Well, okay. Talked about reactors. I've talked about nuclear fuel cycle activities. Some of the nuclear facilities we operate. The Radiochemical Development Facility is the national DOE U-233 National Repository for NNSA, who has responsibility for storage of U-233. This is the old, for those of you that are familiar with Oak Ridge, the 3019 building. This is long-term storage of the national inventory of U-233. We're in the process of, and have started up, a new program to thoroughly inspect this material. This material has been stored for many years in that facility, and there was some question about the inventory data and the condition of the material, so we've started up a new project for NNSA to, on a longer-term basis, inspect all the packages of U-233 in that facility. So we're retrieving packages and inspecting them, doing a non-destructive assay and various other physical measurements to verify their condition. In the process, we are also retrieving thorium-229 to allow that material to be used for medical isotope production.
Is that the U-233 in solution?
It's oxide.
It's oxide?
Stored in packages.
They used to have them in 3019, a bunch of U-233 in solution at one time.
Yeah, and they went through, Tom, help me here, you probably know, the project that solidified that material, CUSP.
Yeah, I worked in the instrumentation for that.
Oh, did you?
Yeah.
Interesting. Well, you know more about this slide than I do then. So, anyway, the material is stored as oxide in canisters, various packages. What we're doing is going back and, of course, verifying the material itself. And the storage, you know, the integrity of the storage, verifying that we can long-term maintain that material. Also, we're in the process of working to consolidate the U-233 that's at Los Alamos and Lawrence Livermore into the inventory at Oak Ridge so that we have DOE's full inventory there. In terms of our active chemical processing operations, the Radiochemical Engineering Development Center, which is really building 7920 and 7930, for those of you that are experienced at Oak Ridge, is where we do the vast majority of our radiochemical processing for heavy actinides. REDC specializes in hot cell radiochemical processing. So when it comes to developing radiochemical processes and demonstrating them with hot material, this is where we do it at Oak Ridge in that set of hot cells. We have the staff and the equipment capability to do all kinds of dissolution separations precipitation techniques in a full remote hot cell environment. And we do work everything from basic R&D to pilot scale demonstrations of fuel cycle techniques. Right now, we're doing separations of targets for Pu-242 and curium-244, americium-243. We're also processing curium targets for the heavy actinides in the DOE's heavy actinide program. In the adjacent facility, Building 7930, we have our staff that specializes in the separation target fabrication. Probably the most important work we do in this facility is the fabrication of californium-252 sources, which are used both in the NNSA missions as well as in industrial uses all over the world. And we also have a californium-252 source loan program where we loan sources to various universities and other users across the U.S. We finish off the separation of our curium targets for heavy actinides in this facility, and we provide in this group also research and clinical quantities of a number of medical isotopes. Tungsten-188 is one of the more important ones that we're producing right now. So this group is very involved in medical isotopes. Those of you that know Dr. Russ Knapp, he now resides in this group, and his medical isotopes group is in this group. On to the isotopes program, we have, and I mentioned, it's not really mentioned on this slide because it recently happened, but we've now been named the DOE's business office for all isotope distribution of all isotopes that DOE produces and distributes. So we now manage the business. If someone wants to order an isotope from another national lab, we still manage the business side of that. They order from us, they do business with us. This group right now is located at the Y-12 plant in the old Calutron facility, for those of you that are familiar with the Calutron facility. And their job is the production and distribution of enriched and stable as well as radioactive isotope products, and they are an ISO 9002 certified and registered operation. And as I indicated, actually this viewgraph's in better shape than I thought. It does have that there. Worldwide sale and lease of enriched isotopes. They'll do custom order chemical and physical form conversions for people that need that done, support non-isotope materials, and we also are working with Theragenics, which has a facility now at the Horizon Center for operation of a plasma separation process for isotope production to commercialize one aspect of that business. The second aspect of our radioisotope program is the radioisotope development and processing group, which resides in Building 3047 at Oak Ridge. These are the people who specialize in producing radioisotopes that are either high beta gamma or high alpha isotopes. And so this is a set of hot cells and glove box operation to produce those isotopes. They particularly have capabilities in beta gamma and alpha materials that can be processed in alpha-free environment in beta gamma hot cells for medical industrial use. So after we separate the isotopes somewhere else, they come to this facility for final processing and packaging and shipping for medical and industrial use, so that we ship out alpha clean isotope packages. They handle all the large DOT shipping casks that we ship isotopes in, and transload virtually everything that we ship out in the isotopes business worldwide in this facility. Iridium-192 is one of the particular isotopes that we deal with in final packaging and shipping in this facility, as well as the tungsten. So those and cobalt-60 sources that we produce and ship worldwide, they all go out of this facility. One of the important new parts of our division is the non-proliferation of national security. And anyone who keeps up with the national energy budget know that this area right now is not only sensitive, to our government and us, but it also is on a rapid growth because our government becomes more and more concerned, I think, daily about what's happening to various weapons-grade material all over the world. How's it being managed? Is it being protected? How good a job are those countries doing? And this area is devoted to helping other countries manage those assets and control. We have two groups that work in this area. There's a Non-Proliferation and Arms Control Assessments group. This group's located at the K-25 plant, and they do a number of areas to support the non-proliferation programs in the government. Steve Baker is the acting group leader. For those of you that know Alex Reedy from the days when he led the team to Kazakhstan, he's on assignment in Afghanistan today, and probably will be for close to a year. So he's really where the rubber meets the road right now. In his absence, Steve is leading this group. This group deals with a lot of non-proliferation areas. Some of the more important that I'll mention are the monitoring the Russian high-enriched uranium, low-enriched uranium blend-down programs in Russia, primarily supplying instrumentation that's being developed by John Mahalzo in the old I&C division. John's now in the Nuclear Science Technology division, and employing that equipment and monitoring the use of that equipment to verify that the blend-down processes that are being employed in Russia are actually getting the job done. This group also spends a lot of their time supporting the U.S. government in making nuclear export determinations. For anybody that's ever gone through that process, and I've been through it a few times in my career, it's not terribly fun, but it's something we do. We look at things that we want to ship overseas to make sure they can pass export control rules. So they also provide bilateral assistance to foreign governments in this area, and they monitor treaty verification kinds of things for DOE. Probably the most rapidly growing part of the Department of Energy is in the material protection control and accounting area in the non-proliferation and threat reduction area. This group, which is led by Larry Sitkowiak, has the job of developing the weapons monitoring and direct weapons use material monitoring equipment in primarily Russia, although other Eastern European countries also. They spend their time helping Russia develop storage containers, secure rail cars and trucks for moving weapons-grade material around Russia, for equipping and monitoring their weapons storage facilities. Sometimes when you look at pictures before controls of weapon storage locations in Russia, it would just scare you to death. And this group comes in and helps them upgrade the security to allow them to protect the material so that it doesn't end up going through Munich Airport or somewhere like that. The materials tend to turn up at times. Also, this group provides a lot of training, support, and technical support to the International Atomic Energy Agency. We have two people that are full-time assignees in Vienna in these areas. Won't spend much time in transportation technologies because you just heard a talk on that recently. Scott Ludwig is the group leader in transportation technologies, and we deal with all aspects of transportation issues related to shipping nuclear and hazardous materials, both advising and developing packages for local and national use, as well as we're called in quite often when problems do occur to help people deal with problem areas. Finally, the nuclear process design and remote systems groups. We have a group that, because we operate all these radiochemical facilities, processes, we have a group that actually does the equipment design because you can't buy any of this out of a catalog, as you well know. This equipment has to be developed, many of it one of a kind. This group deals with everything related to development and operation of radiochemical processes and facilities, the equipment design, operation of facilities, preparation of safety analysis and technical safety requirements, documentation, managing our S&M storage vault that we have at Oak Ridge, and support all of our isotope production area. And finally, when you operate remote facilities, you have to have remote handling systems. This is near and dear to my heart. I was the chair of the Robotics and Remote Systems Division of ANS a few years ago, and spent most of the early part of my career working in this area. We have a group that specializes in implementing robotics, remote handling, and remotely maintained equipment for hazardous, particularly nuclear environments. We're doing a lot of work these days for the spallation neutron source. Some of you have seen our target test facility that we operate, which is probably the only flowing loop with 40,000 pounds of flowing liquid mercury in the world. It's quite an interesting momentum problem when you decide you need to stop the flow, to say the least. That's a rather interesting project. Our primary activities are how to develop the remote handling and remote maintenance techniques so that you can maintain flowing mercury loops without dumping all the mercury on the ground and when they're radioactive to not expose your staff. We also do work for the U.S. Fusion program in the remote handling area. Oak Ridge is the lead for all remote handling, R&D, and design to support the International Fusion program, at least as funded by the United States. So, I hope I've given you a kind of a picture of what we do at Oak Ridge, which was my intent, and give you a feel for who are those people that match up with the research you do and the interest areas that you have. I'll just leave you with maybe these four thoughts. We've made a significant organizational commitment to nuclear and the complementary R&D in Oak Ridge with the formation of this brand new division. We truly expect significant renewed interest in nuclear research and development. Our lab director, Bill Mady, is committed to the nuclear fuel cycle, all aspects of it, and to the renewed interest in that area at the national and international level. We have significant new internal partnering opportunities because we reorganized, and what I'm hoping to do today is at least give you a feel for where we're at and look for those partnering opportunities between this division and UT Nuclear Engineering, because that, I think, is very important to both of us that we're successful at. Thank you very much.
Okay. Let's just go around. Okay, this presentation is now open for questions and comments.
I have a comment, Joe. I'm just totally in awe of your management ability to be able to get your arms around this whole thing. I don't see how you do that.
It's been interesting.
Question I have is, you said you had over 100 guests. Who are they? What are they?
Well, you know, the guests range from every once in a while visitors to full-time guests. So that's subcontractors that are working, and I guess I couldn't off the top of my head tell you the distribution between visiting faculty from UT that are there significant part of the time, or, you know, once a quarter, to full-time subcontractors who are actually involved in doing work directly. We have a number of those. So the 108 guests are in that kind of, and of course that's visiting students, which we always have quite a large number of at any point in time, grad students, postdocs, so it's that whole distribution of guests. So for every one staff, we have 1/3 of a guest. It's roughly the way it works.
How are the resources allocated among these various activities?
Like, they all go get their own. I'm sorry, that's unfair. It varies as a function of the mission. Most of these, well, all of these groups are pretty well independently funded. And of course, you probably many times in your career have met Gordon Michaels, who is our program director at Oak Ridge and manages the overall nuclear endeavor from a programmatic side. The single largest funding for our programs these days is the Non-Proliferation National Security Programs. That's probably half of the funding division, and that's both non-proliferation and the fissile material disposition, as well as the DP programs that we have. So that's pretty much half of the funding in the division resides in that. The rest of it is nuclear energy, and then various work for others in environmental management. Hope that kind of answers your question.
Brent?
Two questions, in case I don't get through it. The funding 238, what's the status of that project? And unrelated, the salt fuel and salt reactor, you mentioned, of course, dealing with the US-6 that were extracted. What's the status of going after the salt?
PU-238, let's start with that one. PU-238, as you know, Oak Ridge was selected as the preferred option for production of PU-238. We're kind of in a holding pattern until the full-blown project actually gets funded nationally, which it has not been funded yet. We're hoping 03 will be the year that project starts. That project will be done in cells D&E of 7930. We're ready. We're still doing development work. Probably the first thing that will happen if it starts in 03 is the Savannah River material will be shipped over, feedstock material. So it's a matter of DOE obtaining the funding to get the full-blown project started. The fuel salts. I don't have a good answer for you right now, so Fred, I'll have to get back to you on that question.
Storage.
It's still in storage. and
just like and 233 oxide.
That's right. And you know, right now when we're going to deal with the traps, and then we have the charcoal bed material and the fuel salt. I guess I don't have a good answer for you. That's
charcoal bed material extracted.
Yes. Yes. I had 3 technicians over there working in that charcoal bed filter area for better part of all of FY01, removing that material. It's now been removed to kind of a de minimis level and is in storage, and that's after we get through with the NAF traps. That's the next material we have to deal with. Fuel salt, I guess I ought to know the answer to that, and I'm embarrassed I don't, but I don't remember right off the top of my head what the status of it is in storage.
Mario?
Slide 2, the one that has Gilliland on top.
Mm-hmm. You want to look at it again?
Yeah.
How do we go back to the very start? Can you do that?
Yeah, we can just do this real quick. It's big. Huh? It's too big again. It's going to take me a while to get that. Let's get the expert up here.
Okay. This is about slide 4, something like that.
Yeah, a lot more than I expected here. All right, let's take a breath.
Just go forward. There you go.
That's what our NRC programs were.
They're now managed by Gordon Michaels. They're actually joined. They have now joined Gordon's nuclear technology program office, and the NRC programs are joined together in one office.
Okay, in the 3 divisions that are darkly colored, those are the only divisions?
That's right.
Divisions that
That's right.
together?
On October 1, we went from 7 divisions to 3. Fusion Energy kind of stayed pretty much as it was. And then the balance of the other 6 divisions, in a crude sense, were put together into these 2, although some went to M&C, some went to Life Sciences, Some went to chemistry division. Some division pieces came to us. But it's really engineering, science, and technology division, which I guess, let's see, that would be a large part of the old DTD and I&C divisions and transportation programs and the energy division. It predominantly went there. Nuclear science, of course, I showed you the 6 divisions it came from. So the idea was to break down the heritage stovepipes and put people together that ought to be working together, and it's working.
You know, there's a lot of housekeeping involved in this sort of thing. Is there an associate division director or something that helps support?
No, we have in the new organizational construct, we have no section heads. That position was eliminated. So we have group leaders reporting to division directors, who reports to associate lab directors.
Okay. Any other questions or comments for Joe? I do see 1 or 2 new faces, and you may not know that we do have refreshments downstairs, and everyone is invited to join for refreshments. But before we adjourn, let's express our appreciation again to Joe for his presentation.
Listen to what I was learning about. Now the section heads have to get those. I'm actually, how well is working?